For example 3, I am going to be finding the operations on the following functions f and g, and then we're going to find the domain. So let's start by just finding the operations on each function. I'll start with f plus g of x, which means f of x plus g of x. And then I'm going to go ahead and write down f of x, which is x minus 4. And I'm going to add that to g of x, which is the square root of x plus 5. And that's done. You cannot simplify that any further. There's nothing to combine or distribute. And we're finished. But we still have to find the domain. I haven't done that yet. And the domain of f plus g of x, as well as f minus g and times g, is the intersection or overlap of the domains of f and g. So let's find the domain of f and g and figure out where they intersect. The domain of f is just all real numbers. I do not have an x in a fraction or underneath a fraction bar, and I do not have a radical symbol, so there's nothing to worry about. Domain's all real numbers. But g of x has an even radical, and you cannot have a negative underneath that radical symbol, that even radical, after you calculate everything out. So we want to figure out what makes that positive or equal to 0 underneath. It has to be 0 or greater. So to figure out what makes x plus 5 calculate out to be 0 or greater and not negative, you take x plus 5 and you set it greater than or equal to 0. Subtract 5 from both sides, you get x has to be greater than or equal to negative 5. And the domain written in interval notation would be negative 5, including with a bracket, all the way up to infinity. And so we want the intersection of both of those domains. And I'm just going to write it out graphically for you for example 3a so you can see that visual. The domain of f is the entire number line. It's all real numbers. But the domain of g only goes from negative 5 up to infinity. And so you need the intersection of both of those domains which would be right here. Both number lines are shaded in at this part. It's where they intersect or they overlap, or it's what they have in common. So the domain of your f plus g of x is this intersection right here, and that goes from negative 5 to infinity. All right, next let's do f minus g of x, which is just f of x minus g of x. And my f of x function is x plus 4, and I'm going to subtract off g of x, which is the square root of x plus 5. Normally I say to put parentheses around the function you're subtracting to make sure you are subtracting the entire function and not just the term that comes first, but because there's already a square root bar, or a square root symbol I should say, over top of x plus 5, we don't really need to have those parentheses there, and that's that. And the domain is, once again, the intersection or overlap of f and g, and we already found that for f plus g of x. You don't have to find it again. We're just going to copy it over, and the domain, sorry this is sloppy, the domain of f minus g is negative 5 to infinity, including negative 5. So let's go ahead and do f times g. F times g of x is f of x times g of x. And that is going to be x minus 4 times the square root of x plus 5. You want to make sure you're multiplying the entire functions together, like each entire function by the other. So you're going to use parentheses to do that. I don't technically need parentheses around the square root of x plus 5 because of that root symbol that's there. It's enclosing everything underneath. So those extra parentheses you can just take away. And there you have it. That's simplified. And the domain is nice and easy because once you find the domain for f plus g and f minus g, you have the same domain for f times g. It's the same for all three of those operations. Plus minus times is the intersection of the domains of the original two functions, so that doesn't change. Now the only time that the domain does change from just the intersection is when you build a fraction. So in D and E, we're making a fraction up, and we are now putting an x expression in the denominator, and you cannot have that calculate out to exactly equal to 0. So the domain for D and E is going to be that intersection up top that we found, excluding whatever makes the denominator 0. We're going to have to take some numbers back. All right, so let's go ahead and do D, which is going to be f of x divided by g of x. And our f of x function is x minus 4, and then g of x is square root of x plus 5. The domain is going to be the intersection except for whatever makes your denominator equal to 0, because now you have x's in the bottom of a fraction bar, and that can't calculate out to be 0. It cannot be 0. So figure out what makes it 0, and then we'll take that back. And also, I kind of forgot to say that this is as simplified as it gets. There's nothing really to do with that. You don't have to multiply by, you don't have to rationalize the denominator or anything. You can just leave it like that. All right, so let's figure out what makes x plus 5 equal to 0 exactly. And if I subtract 5 from both sides, I find that x is equal to negative 5. However, that's the value that x cannot equal. So our domain, or our intersection of f plus g minus g and times g went from negative 5 to infinity. But now we're saying that x can no longer equal negative 5 because it makes our denominator 0. So we're going to take that back. And the domain of f divided by g is going to be from negative 5, not including all the way up to infinity. I was looking for my eraser, and I'm not sure where it was in here because I switched trying programs because the other one was driving me crazy, and I'm not really that familiar with this, so I apologize, but there you have it. So we started with the overlap of negative 5 to infinity, and I stole back my negative 5 because that makes my denominator 0. And now you have the domain going from negative and 5, not including to infinity. All right, g divided by f of x is g of x over f of x. And that is equal to the square root of x plus 5 over x minus 4. And my denominator cannot equal 0 now that I've created a fraction with my new function. So I'm going to figure out what makes x minus 4 equal to 0 and then take it out of my overlapping domain. So the domain of the overlap went from negative 5, including it, up to infinity. That's the original intersection of f and g. And then we are going to take back whatever makes my denominator equal to 0. So I have x minus 4 equal to 0. Solve it, you get x equal to 4, and technically that's what it can equal. So I'm going to come over here to 4, and I'm going to take that out of my domain. Let's see if I can find the eraser a little faster this time and get rid of it. And draw my little open circle again. All right, that's pretty sloppy, but I'm not doing this over for now. I'll do another video another day, make it better. All right, so the domain that we have for this is going to go from -5, including -5 again, up to 4. And then we need to skip over 4 and end at infinity, or go to infinity. And then finally we have f times f, which is f of x times another f of x. And f of x is x minus 4 times another x minus 4. And that is x squared minus 4x minus 4x, which will combine to -8x plus 16. And the domain is just going to be the intersection of f with itself, which is going to be all real numbers. And sorry that this video was not fabulous, but I was having pen issues and switched to a new program, which I'm not that familiar with. So at some point I am going to redo it and hopefully do a little better explanation and not worry about the technicalities of how to get an eraser to work or my colors to change and so on.